Well, just the same, let's see. I would like someone to put the work up for this. So, number 3 over here, number 7 over there. So group 2, can you guys set up number 3? And group 1, also known as Roman, can you do number 7? Just the setup? And would you get as an answer?
Oh, like all the way.
Like you can just write the answer at the bottom. We'll assume that people can do the arithmetic. Okay. So number 3, the point in number 3, you could have done it as the cubed root of x minus the square root of x. Doing top minus bottom, but this is so much easier. Roman, would you get as an answer for, in the end, for number 7?
For 7, I got 5/6.
6, I agree. So you guys said 3 and 7 were simple enough. And 11 is just a parabola that you do 2 minus the parabola. Well, could have just shifted everything. 17 was an issue. 17. That was helpful. First of all, drawing it. People had issues. How do you draw graph absolute value? Well, you need to know, like in calculus, they always split it into a piecewise function. But where does it hit 0? Where does x squared minus 4 hit 0? At positive 2 and negative 2. And anywhere that the graph was going to be negative, it flips up. So when it's bigger than 2, would you guys notice the notation of this? Do you understand what that means? The absolute value of 2 is greater than 2. That means either 2 was greater than, or x was greater than 2, or x is less than negative 2. Okay. As AP gets mean, and sometimes they're like, oh, you're all smart, you can handle this. Check homework, can you show me? So are we okay with getting the graph? Because they may or may not give you a calculator for this. So I'm finding intersection points. I've got some coordinates. This is definitely not a right minus left. So what we're looking for is kind of like the back end part of the two wings. So I want region 1 and region 2 doubled. So region 1, the blue curve on top is still always the top curve. So I could have just integrated that from 0 to 4, but I'm not going to. So blue curve minus this part of the red curve, this part of the red curve is this negative quadratic. So integrating that, things cleaned up nicely when I distributed the negatives, I get 4. For this little bit, region 2. Same top curve as the blue one. Bottom curve is the regular old X squared minus 4 happy face parabola. And did I actually finish it? Possibly not. For -64, 32 thirds plus 32. I'm not doing it in my head very well. In the end, what did you guys get as an answer? Yes, no? So whatever came out of this, I would need to add them together. And then multiply by 2. Okay with that one? All right. So I want you guys to fight through 35. So I want 2 people from a group to come up and try and draw it. Group 5, you're all alone, so you can also take group 4. Because you need support. So group 4 and 5 can get there, and you guys try and draw what the problems you're asking us to do. George, did you get 7? Both draw at the same time. That's all helpful or out, I don't know. Okay, so the problem says you have a parabola and y equals 4, and there's going to be some horizontal line that slices that area exactly into half. And notice they did not make the line y equals 2. They put it as y equals c and made it a little bit above. They don't know the answer yet, but why do they intuitively know that it's going to be above 2? Because the less area in the little happy face part. Okay. Can someone come up and show us how to get those coordinates? Adrian and Naomi, how do we get the coordinates? Well, I'll give you this one. This one's 0, 0. What are these 2 coordinates? Adrian, what do you have?
For the rightmost one, it's -√c, C.
here?
Is it 2,4?
Yes, 2, 4. Okay. And I have the rest of the question covered up. It asks you to solve this with respect to X and with respect to Y, I think. So, how do we find C? Group 9. What do we do? What is, first of all, would you rather do with respect to X or with respect to Y? Because that way, yeah, okay. So with respect to Y, what would you do? There's-
So 0 to 4, sorry. 0 to 4. Through Y. Multiply the whole thing by 2 and outside.
So 0 to 4, integrating that whole thing, and then doubling it, gives us the whole area. Do I even need to double it though? Like, it's a complication, I just don't care. Okay. Y, 4 to the 3 halves, square root first, and then cube it, so square root of 2 cubed is 8 16/3. That's the area of the whole thing. How does this help me? Divide by 2 is useful. So whatever that is 8/3. How is this gonna help me? Next.
Do the integral of that region, so I guess that would be, instead of equal to 8/3. I mean, you can do it a different way with respect to Y, that kind of works out nicer, but that's what's, you can do for respect to X.
Okay,
Yeah.
so I think what he just said was, we're gonna do the same integral again that Evan set up. But then it's not gonna be 0 to 4, it's gonna be 0 to what? C or root C? 50-50 guess.
C. Root C.
You phoned a friend. So integrating from 0 to the Y value, this, what is that, Ben? And then only, what is that supposed to equal? Good job, Ben. So there's your setup. And we already did the integration over here. Equals 2/3 Y to the 3 halves from 0 to C. I'm plugging in 0, I get 0. So 4 equals C to the 3 halves. And so it's 2. No, this. 4 squared then to the 1/3. And I believe they wrote it as a funny thing, like 2 to the 4/3. Yes, no? So that's with respect to Y, which is easier. But, and there's a lot of ways you could do this, and some of them are fiendishly complicated. But I like the way, Evan started this one. He said, I'm gonna find the area of the whole thing, and then find the spot that gives me just half. And I would do that same process with the X's. I would integrate from 0 to 2, find the whole thing. And then 0 to root C, when does it give me half of that whole thing? Should we set that up, or are you guys, actually, we'll have you guys set that up. So, I looked at them all. Can you guys set up, how to find, I don't know, the whole area or the half area, I don't know, well, with respect to X? Ooh, actually, you do the whole area and you two do the, piece. Ha-ha. Divide and conquer. Left versus right. And if you haven't been looking at the schedule, I plotted things out through the AP exam. You have a quiz this Friday on 7.1 to 7.3. Remember, 7.1 is net versus total displacement. Squirrel's running along. What does it show on his Fitbit versus where did he end up from where he started? Integration gives you displacement. How much did it change from where it started? And total, that's wearing a Fitbit. He ran around a circle, landed where he started. His displacement is 0, but maybe he ran 4 miles. This is 7.2, which is area between 2 curves. And I can ask you things that's what, you can both write on the board at the same time, by the way.
Yeah, we're a little confused.
Oh, well,
Yeah.
there will be support. So, yeah, so 7.2, area between curves, and then 7.3, I call them Play-Doh problems. 7.3 are the things that are up on the walls, 3D things popping up out of,
Yeah, it's just, I mean,
This
I'm
is
doing
two.
it from G, yeah, you could just do it from 0 to 2.
and Julia and Claudia, I checked homework, can you show me? And then chapter 7 is Friday after.
So you can just do
Why, no, we just want first thing.
That's fine. I'm just, yeah. and
So
with
is this
respect-
half the area?
Yeah, this would be half of it, 'cause just from 0 to 2, what would be.
Okay.
So this should work.
Okay, we're struggling with the second part. So let's make sure. Okay, so they get the same overall area with respect to X. So how do we do the halfway? How about we do the same thing that we did with, instead of 0 to 2, you're going 0 to what?
1.
What's the X value where the halfway point meets? This is why I asked Naomi and Adrian for the coordinate. Root C. So integrate 0, you can actually, okay.
Yeah.
It's hard to write that way, that's all.
And then is equal to 8 over 3?
Yes.
Okay. Is equal to 8 over 3.
Okay, all right. So you guys can sit down. You survive. the integration for us. And plug in, because the integration's kind of already been done. Yeah, I was gonna say, Kari, just because you picked the card doesn't mean you have to be the one, but. So integrating the left, I mean, Max has already got it written, so
Yeah.
4x minus x cubed over 3.
Should I write it?
Yeah. And then we need to evaluate it.
0 root c.
Equals 8/3. And now Stella, how do we plug in that root c?
Not just 4 root c.
Okay,
Okay.
this is the next piece that's harder.
C to the
Okay.
That works. C to the
It's
over 2
technically
also
right.
works.
So then what does that become? Like, that's a big ol'
Yeah,
mess.
maybe I shouldn't have done that. Can I erase?
Well, no, I mean,
Can I erase
and-
it and put like a over 2 and then make it like pretty?
well, no, because we'll fix that. We'll add space too. So how do I add 4 root c minus c to the 2/3 over 3? Like, what do we, how, what do we do from here? What? Okay, we need to combine them somehow. How do we combine them? Okay,
Yeah, I can do that. But root c goes back up, root c. Or just go ahead. Because I wanted to rewrite it as c to the 1/2, so I'm like, no. Okay. And then. Well, I think I see it figured out. I'm getting confused.
me too. Okay, so guys, what are we doing? Okay, okay. This is hard. Stella really wants this to be written as a fraction, so.
Yeah.
Dyslexics untie.
Then could you factor out the, like, C over 3? Or?
Well, we can
Or, I mean,
multiply
make it
everything.
over 3 and then just, yeah. And then. Exactly, yeah, that's better, that's better.
Zach, they're looking to you. Cameron, suggestions?
Is that like not, is that right? Did I make, is that, I don't know about that one.
I mean, that's not invalid.
That doesn't helpful, yeah. Wait, what?
Okay, maybe the answer is, we should not do it with respect to x. Yeah, what's,
Yeah,
yeah?
You can do, I mean, there's a different way that kind of works out nicely.
Okay, how did you do it differently?
I mean, the way I did it, I set it up, the integral from negative c to, negative root c to c of c minus x squared, with respect to x equals 16/3. Yeah.
Okay.
Maybe the numbers work out a lot
and then, like-
nicer that way.
So,
Yeah. Cause you wouldn't have this term.
these guys are saying going from negative root c to positive root c, because then these things were gonna, coefficients are gonna, or sorry, exponents are gonna match. Okay, so you said the whole thing, negative root c to c, and it equals 16/3, and that makes it so much easier. Okay,
Or you have to change what's actually in the, so you do c minus x squared as
C
the,
minus
whatever thing inside is called.
the argument.
Argument, yeah, there we go.
Okay. So top curve minus bottom curve. You guys okay with that? And now we all have like halves of root c. Plugging in a negative root c, don't I get that again? Doesn't it just double? And we get the same answer we had before. Okay, with respect to x and with respect to y, it's a matter of looking at it and seeing which thing works better. Definitely this one, going with respect to y is so much easier. And when they're feeling mean, the AP will put something like this on the free response questions. Oh, find the vertical line or find the horizontal line that cuts this exactly in half. Or where it rotates and half the volume is above and half the volume is below. Alright. Were there any other questions with these guys? Or the day before? Were there any from the just X's that were challenging that we need to go over? 33 was a warm-up that we did a couple days ago. This one is just tedious, but it's doable. Yes, Amelia.
27 from 85.
Okay, I don't have it up here, so it makes me think 27 was not assigned, but,
What is 27?
That's what I got.
We're on the same page.
Am I writing this correctly? X squared?
X. Which is y equals x.
Okay. You guys remember how to graph sine pi over 2? we will do some trig reminders. What's the amplitude of the trig function? 1. What's the period of this trig function? 2 pi divided by the b value. Weird. Period is 4. And vertical shift and phase shift, no? So sine starts at 0, ends in 0, it's not reflected, so normally goes up, not reflected, so there we go. And y equals 1 minus x. Karen, what's the y-intercept of that? 1. Katie, what's the slope of the straight line? What's the slope of this line? 1. Negative 1? So the question is asking us to do what? Find the area enclosed. Did I graph it wrong? Why is my line not cutting through?
It's y equals x, not 1 minus x.
Oh. 27. I keep looking at 26. That's why. That's better. Okay. Group 8. How do we set it up?
The integral from 0 to where it intersects.
And I didn't draw it great. Does the red line go through the coordinate 1, 1? Yes or no? So it should go through. And so sorry, so say again, what do I set up?
The integral from 0 to 1, and then you're gonna do sine x, sine pi over 2 x minus x.
Okay. Group 7, how do I integrate that?
So we chain rules, so we do, well, not really.
I'm doing chain rule.
Yeah, so, negative cosine divided by pi, or divided by pi over 2, so, 2 pi. And then minus x squared over 2.
Okay, so then plugging in 1, what is cosine of pi over 2? Okay, on the unit circle, cosine, sine, which one is the x value?
Cosine of x value.
What's the x value at pi over 2? Oh, how convenient. So 0, I don't care about the rest of the stuff, minus 1/2. But now cosine is 0,
Cosine of 0 is
it's 1. So 1 times, okay. And 0 in that. So it looks like 2 over pi minus 1/2. Yes? Any other questions from anything chapter 7? You're in the side-eye, Ben, what's up? Okay. I want to, we have a little bit of extra time. I want to show you some visualizations of the next section, because that's the hard part, is what does it look like? Oh yeah, and then geometry. Semicircles or rectangles? Or semicircles or squares? Squares. So if I tell you between the x-axis and sine x, I'm gonna have shapes that come up out of this that are squares. And the length of this square runs from the curve to the x-axis. Is the square gonna be the same size no matter what cross-section I take? No, it's gonna change. So there's that square. And there's that square. There's a little square. What is the overall solid gonna look like? So say you just looked at the wall. So I do have a few of them. So kind of behind George over there is the rectangles coming up out of the wall. So it's hard to see what it's gonna look like. And did I show you this last week? Okay, I'll show you now. If you go to Canvas, as usual, stuff is posted. This top link is different for this unit than others. I'm showing 3 different programs that, or 5, whatever, 6, that will help show what's going on. And of course, we said squares, and that one doesn't do squares. Well, we'll try it anyway. And it takes a minute to load. And this has 2 different curves. There's a red curve and a blue curve, and it will get there eventually. Go, little engine. Okay, there's my 1 square. And see how the size of the square changes depending on where it is, yeah? So if I put in a couple of squares, whee, or if I fill it up, what is that solid gonna look like? It's gonna kind of look like that. So 7.3 is part of this, which is finding volumes of known cross sections. So the cross sections are all squares in this case. All right, how's it gonna look different? Can you visualize it? What's it gonna be if it's a triangle? Equilateral triangle. I kind of see it as a mohawk fish, a ridged croissant, I don't know. And it's got like a little curve to its snoot. Now it really looks like a fish with a mohawk, because I put semicircles on at the same time. Semicircle looks like one of those silverfish bugs. Anyway,
I recommend that you toy with these when we do 7.3 tomorrow, so you can see what's happening to the shape as it moves along, and what the surface looks like as you go. Okay, and in the land of why do I even need to know this? Have you guys ever had those candies shaped like shells or whatever? And they have these specially made molds that hold each, like there's the starfish one and there's the conch shell one, whatever, the shapes that need to hold those stupid little candies. They're all weird looking, or any of those specialized earbuds or products, the form that holds them is weird looking. How much, this is a thing you don't have to do, but surface area, we don't calculate surface area, they dropped that from the curriculum about 20 years ago. But you need to find the volume, like how much space. That's not as useful. How much like cardboard indent do you have to use to make something to hold that weird shaped electronic thing that you just bought? That's one of these problems. Do you guys know what golden rectangles are? They're cool. That's, if you have a square and a rectangle glued on, and then you make another square that shape, it's golden rectangle. And another square this way, or maybe we go smaller. And that one's not one word. But, you seen that before? So, golden ratio is 1.618, blah, 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 it's a repeating number, it's phi. Mr. Careless has a tattoo of that, she'll be happy to tell you all about the golden ratio. But it's where the length of this square, that ratio compared to, if you glued a little rectangle on top. And people that have the golden ratio is, the closer someone is to golden ratio, they are considered more beautiful. Your height to the ground versus your belly button to ground. If you are in one, if the ratio is 1.618, the closer you are to that, that is deemed the beautiful dimensions. And the height of your head versus eyes to your chin, like top of your head to your chin, and eyes to your chin, that's golden ratio. The closer you are in that ratio. Lots of them all over the place. Artists, help me out here. All right, bye guys.